Cave formation. Cave formations are created when acid reacts with limestone or a rock containing 80% or more calcium carbonate. These formations are found on the walls, ceilings, and floors of caves. Cave formations are called speleologium, from the Greek word speleon, meaning cave, and sema, meaning deposit. A number of conditions need to be present for speleologium to form within a karst environment. First, the type of rock within and surrounding the cave needs to have an 80% content of calcium carbonate, which is usually limestone, dolomite, or similar types of rock. The bedrock also needs to be highly fractured or jointed so the water can flow through or follow through these joints or fractures. The bedrock also needs to be relatively close or at the surface. The fourth requirement for karst and speleologium formation is relatively moderate annual rainfall. The final requirement to form the speleologium is vegetation cover. Vegetation enhances the karst process by producing more available acid. A few variable factors including humidity, temperature, and air flow through the cave also play an important role in speleologium formation. Caves and their features form the rainwater follows the cracks or joints in the rock material, usually limestone or dolomite. The rainwater combined with carbon dioxide forms a weak acid called carbonic acid. This weak acid, once in contact with limestone, begins to dissolve the limestone. The process slowly creates larger and larger cracks and joints. The acid can remain at a consistent level, but often is strengthened due to increased amounts of carbon dioxide dissolve large channels, networks of channels and joints, and actual caves become stuck. Once the caves and network of channels have formed, different types of cave formations begin to evolve. Many different speleologiums are common in caves, including stalactites, stalagmites, columns, ringstone, pools, cave burrows, and bacon strips. So stalactites are just one drop of water on the ceiling of a cave is all that is needed for a stalactite to start forming. Each drop contains a small amount of dissolved limestone that has been acquired from flowing through the cracks and joints of the bedrock. Once this drop is hanging suspended from the ceiling, some of the contained carbon dioxide escapes the droplet. Due to this carbon dioxide escaping, the droplet can hold as much limestone, so a thin external ring is formed. After the drop falls, a small layer is left as a residual. After multiple drops have fallen, the dripstone forms a hollow stalactite. So that's why stalactite is made. So these stalactites are called soda straw. As growth continues, the soda straw regularly becomes sludge by the deposition. The limestone-rich droplets are now forced outside of the soda straw or the stalactite, creating the droplets to leave a small paper trail of limestone. This results in the cone and shaped dripstones. Average growth rates for dripstones or stalactites are about ½ inch for every 100 years. When multiple soda straws or dripstones joined together, a bacon strip is formed. These features usually form along a joint where multiple dripstones and stalactites can form.